Welcome to a two-part tutorial on how to graph a castle. Now before we get started, I need you to right click on the link in the description below and open it in a new tab. There you will find these three equations down here. So first one may look familiar if you've watched my tutorial on how to graph a saw blade. This equation is mentioned in there. And these next two equations are new. So first one is so this is called a not triangle wave. This is called a square wave. And even though it looks like a rectangle, they look more like rectangle waves. They call them square waves. And this next equation here is an approximation of that square wave. So you can see it's close, but not. But it is not exact. It still looks a bit off, and these are called Fourier series. So so Fourier series they approximate harmonic equations, or they approximate cyclical equations. I think is what they're called, like this one here. And obviously, if you add more terms, you can get a more accurate approximation. Now they're not exact, they're not one-on-one because I did not derive this equation from this one here. This is another way of approximating this function here. The reason we're doing that is that if you may have noticed that on my screen here that these vertical lines are glitchy over here, and so if you take it, how did I delete that? So if you take an approximate equation like this one, you can see that you see no glitches happening. And of course, the more terms you add, the more accurate of an approximation you get. And so if you prefer to use this approximated one, it's available in there. But one way to use is this one. This one over here. So this is going to be those top. If you look at if you look at the top of castles, you can see these square waves at the top. I'll keep moving so you can get a better idea of what I'm talking about here. Now I'm going to copy this equation because it's the one that I'm going to use, and now we can collapse this and make a new folder where we actually put all the functions that we want to use, and I want to paste it in here. Now, normally on castles, like you don't just see this room here. Actually, before we get it too far ahead here, what we want to do is we want to define where from where to where we want, like how much wave we want, and how frequently we want them to occur. So some controls. If you so like any harmonic, if you put a scalar in the front, you change your amplitude. So originally it was just 1 because multiplying by 1, and so you can see your amplitude is it's amplitude of 1 from y equals -1 to y equals 1, and then and if you put a 2 in front of it, you span from -2 to 2. And if you want to change the width, similarly you can divide by scalar. It doesn't have to be 2. You can put a 3 here. All right, give the idea. I always stick with 1 for simplicity, and I can make less embarrassments if we stick with 1s. Now, if you want to get your range, so I want to pick from this point here to this point here. So three ups and downs. And as you can see here, that Desmos has conveniently labeled these points. It's given the exact value of minus 2 pi over here and 3 pi over here. So we know these ranges. In that case, the way we do that is go minus 2 pi is x is between minus 2 pi and 3 pi here. So we got these values. Now, the next thing we need is we're gonna need to complete the lines on the ends here. So we want to show the whole. We want to show the entire vertical lines, and just because this glitch is very annoying, I'm going to hand add them here. You can skip this step if you're using this equation here. You may feel free to skip this step, but I'm going to demo how to do it for those who are as bothered about it as I am. And the way you do it is you can pick on these ranges here, and we're not using y's, we're using x's because we want vertical lines. And want negative pi, and we want 3 pi. So we want to go, and we know that the range is from minus 1 to 1. And we also want to line it at the bottom here. So that is from. So that we know, we want a y at this bottom line here. This is minus 1. And that's going to span from this range here. So this is looking better. All right. Now what we want to do next is let's draw some horizontal lines from. I want to approximate. We draw horizontal lines kind of coming down on the sides here, and I want to start with. These numbers are arbitrarily chosen. You don't have to use them. This is your castle. We know we want y2 to be at least at this top bound here, and let's say I want to end at around about minus 10. So let's do that. Alright, now the challenge of figuring out where we want this other line to be. So we know that we need to go with that. So we need a difference between minus 2 pi and minus 4. That's the same difference as doing 2 pi minus 4. And we know that this end is 3 pi, so let's start with 3 pi. If you don't want to find the exact, if you don't want to simplify your expression, you are allowed to type expressions in here, and Desmos will figure it out what the value is for you. And so we want to subtract what is 2 pi minus 4. Alright, how do I get a plus? Well, I got it by my opening parentheses. So I skipped a step in front of you. Alright, if we do a bit of simplification, for those who actually want to do it, so this is actually minus 5 pi plus 4, if I did the math correctly. Now this is 3 pi minus 2 pi is just pi minus 4. No, plus 4. Sorry. Because if you distribute minus sign over parentheses, you have to flip the signs. Right, and we want the same y range, and there we have it. And now for the last line, just to make it a tad bit more exciting than just a bunch of straight lines. And so I want to use a wide ellipse that spans between -4 and I'm not going to calculate that 3 pi plus 4. So that's why the decimals are the same digit as pi, but it's a 7 because we added 4 to 3. All right, and we know that's so put a minus of the square root because we want the bottom half of an ellipse. If you want the top half, then you just keep it positive. I'm going to do 1 minus x. Put a placeholder value for now. We can figure that out soon. The way you find the center is you want the average of -4 and this value here. So the average of that is this is pi plus 4. And we want to minus -4, so that's plus 4. Make the math easier. This is pi plus 4. This is 4 over here. So that value is 8 plus 4, but we want half of that. And here's a trick on how you get your decimals, on how you can get a fraction. So let's say I did this. And what you should be able to do is you can highlight it and then strip do a division. So take the average of the two. Alright, it's just a math off cam. You want to add 4 to account for the distance from this value here. Alright, and then we'll subtract 10. Because, okay, why do I subtract 10? Because this ellipse ended at 0, so if you want to move it down to -10, you just simply subtract 10. And then now to get the width of it, if we want to get the width of it, so we know the distance is pi plus 8 over 2, as I was scratching out the math. And so you take that value and you square it. So these are all exact values here. Then I'm going to finally change all these to, you can use whatever color you want. Now, this is only one part of a castle, and if I recorded the entire process to make the whole castle, that'll make these tutorials too long, and I'm not going to make you sit through however long that's going to take to make this same castle piece here on another side and then drawing another block in the center. And so I'm going to leave that to you to do it. In the next video, what I'm going to show is I would already have the other side done. I would already have the middle piece done, and I'll show you how to incorporate, like how to use. All right. If you want organizations to actually work, you want to make sure that they're indented in the folder. in the next video, I will show you how you can use this triangle wave here, so you don't have to keep making absolute value functions. So in a sense, this will go on top of this section here, on this top here, and and as a bonus, we'll put a flag on top of them. All right. So hope you enjoyed this video, and I'll see you next one.